When I select a geometry, I will see the shader that is connected to that geometry. But there is another way of finding and manipulating the shaders. If we go on the window and rendering editors, here is something that is called the hypershade. If we open up that window, we will see the different shaders that we have in the scene. We have the aluminum shader and the default Lambert shader. If I select the aluminum shader and then press this button, Input and Output Connections, then in the bottom of the interface here, I will see a graphical representation of the shader network. And a shader network is a collection of different nodes. Maya is really built up of different nodes, and a node is basically a list of attributes. So if we, for example, select the sphere here, we have the 4 different tabs here. Every tab is a specific node, and as you see, the different nodes have different attributes, and all these attributes in these 4 nodes together they define the sphere. And it's the same with the cube. All these 4 nodes together they define the cube. And as you see, the aluminum tab is available on both of these. So the sphere and the cube share one node, and that node is the aluminum node. But in the same way that a sphere can be composed of 4 different nodes, a shader that is a material can also be composed of several nodes. And that is what we see here. The default is that every shader, every material is composed of 2 nodes. And as I will show, I can add more nodes when I make the shader more complex. And we will soon see how that looks. But this is the shader network. I will get back to that very soon. But another thing with shaders is that they can be complex in, so to speak, 3 different levels. If we look on the color, for example, on this shader, I would say that this is the first level of complexity, that it has a homogeneous color to it with no details in it. And it doesn't give a very realistic impression. And that kind of very simple homogenic textures or shaders are primarily useful for objects that are very far away and you don't need any details in the surface. For other parts of a model, when you are more close, you usually need some kind of texture or some kind of changes in the surface. If I render this one, for example, it will look perfectly flat and not really realistic or interesting. So in order to take this shader to the next level, so to speak, level 2, I need to give it a texture. And when I give it a texture, it will not have a homogeneous color on it. It will have a texture in the color. And I add a texture by clicking on this small checkerboard icon at the right here. When I do that, I open up this Create Render Node section, and here I can create different sorts of textures. And almost all of these are procedurals, and that is the, so to speak, level 2 complexity of a shader, that it uses procedurals. And a procedural is a mathematically calculated texture that you can define with an algorithm. A checkerboard pattern, for example, is a very good example. It is very easily described mathematically. So I select that checkerboard pattern. And now we see a node here that describes this checkerboard pattern. And we have the different colors here, for example, the white and the black one. I can change the color here. I can also add a new texture to this texture by clicking on the checkerboard pattern again. And for example, assign a more chaotic texture like the cloud here. And this one I can also manipulate further on. If we look to the left here, we don't see the shader anymore. If I go to shading and hardware texturing, if I turn hardware texturing on, I can see somewhat how it will look, but not perfectly. I see just a kind of approximation of how the geometry look now. So in order to, when I build more advanced textures, I need to render the image in order to see how it really looks. And this is how it really looks. As you see, the gray color of the checkerboard is combined with this cloud texture here. So it is like mixing different textures. And you can have lots of different textures to create very complex effects. And the procedurals usually doesn't look very realistic, not when you apply one procedural. But if you combine different procedurals, you can achieve surface materials that look quite realistic, at least simple materials like a metal surface. But I will get back to how to make the shader even more advanced. I will get back to that very quickly. But before that, I want to show you how this looks in the hypershade. If I select the aluminum shader and click on Input-Output Connection, then we'll see that the shader is now more complex. It has the checkerboard texture, and connected to that one we have the cloud texture, and these two combine into the aluminum shader. So now we start to see more clearly what we mean with a shader network. That we have this network of different nodes, and together they form this special shader here. And as you see, the connections here have a small arrow to it, so you can kind of jump between the different nodes. And that is what you do with these two arrows here. If I press these arrows, I can jump between the shaders, and now I have kind of jumped up to the top of the hierarchy, and I am at the aluminum node, where I have this basic transparency, ambient color, and so on. And I have applied the textures to the color, but I can also do that applying it to the other ones. Like, for example, I can apply it to specular roll-off, for example. Give that another look. The noise for example, which is also a procedural with a chaotic style to it. If I render the image now, you will see, well, it's a little bit hard to see maybe, but the specular is not perfectly flat now. In order to show that, I can take away the texture from the color. I do that by clicking right-click and break connection. So now the shader has only this gray surface to it. We can give it a blue surface at least, but now it's a flat homogeneous color. But the specular still have a texture applied to it. So when I render this image, the color of it will be homogeneous, but the specular will be irregular. And that is why we see this irregularity on the surface.